Hi everyone. Today I'm here to talk about credit cards and specifically the validation of the credit card numbers. My name is Jorian Korte and I welcome you to the presentation of our project. I'm here with my team members called Aran Loss,
Hello.
Daniele Maggiora,
Hello, everyone.
and Louis Blanco.
Hi.
The tasks were split accordingly. Louis, he wrote the Python code and he also worked on the video presentation. Aran, he did pseudocode and also wrote on the project report. Finally, did the video presentation as well. Danielle and I worked on the flowchart together, and Danielle also made the project report and video presentation. And I also worked on the project report and the video presentation. We will show you the process of our approach in short and take you along the problem, our approach, the obstacles, and the solution. Well, we talked about credit cards, and each of these cards have a unique card number associated with it. This is the number that is used to validate the card at the time of carrying out transactions. So, in order to carry out a transaction, the credit card, of course, needs to be valid, and that is for the purpose of safety and reliability. I mean, imagine going to a bank and you're there with a credit card which isn't even validated. Well, then you can get money. This again stresses the importance of validating the credit card number. The number of all credit cards and debit cards as well, but we're talking about credit cards now, must comply with a complex formula called the Loon algorithm. In order to validate the credit cards ourselves, we need to simulate a program that follows the Loon algorithm.
So Hans-Peter Loon developed this checksum algorithm to check a card number's validity or not. It consists in taking the card number in question, multiplying every second digit by 2, starting from the right, and if a multiplied number is greater or equal to 10, then the algorithm adds the digits of the product to get a single-digit number. If the last digit of the addition of the multiplied numbers and the untouched ones is equal to 0, then the algorithm returns that the card number is valid.
To approach the problem, we decided to use the divide and conquer strategy, which divides the problem in a series of sub-problems that we were then able to split and to work on separately. A flowchart, which is a visual representation of the code with different shapes representing different operations, helped us a lot in the process because visualizing what we actually had to do was great in the choosing of where to split in sub-problems.
Now, throughout the project, we overcame many obstacles. After fully understanding the Loon algorithm and how it works, the first obstacle we encountered regarding how to implement the Loon algorithm into Python code was how to code the system so that it would only take every second item in the list from the back. The problem here lies in the fact that in the Loon algorithm, every second item in the list would need to be doubled in order for the algorithm to work. Now, how this obstacle was overcome was through using an equation with the indices of the items on the list. As each item in the list has its own index number, these indices can be used in an algorithm to only pick the necessary items from the list to double them. Thus, the code finds every second item on the list by calculating whether the index number of the list is divisible by 2 without making a decimal, and for this operation, the operator modulus was used as shown in the top red box. And since the list starts with index 0, each second item would have an odd number, so the first second item would have the index of 1, then it would be 3, then it would be 5, and so on. So, with the if statement, only the items with the index number of 1, 3, and 5 and odd numbers were chosen. Additionally, another obstacle that was found was how to code the system to add the 2 digits of a number when it was doubled and became greater or equal to 10. However, after some thought, it became clear that this issue was more simple than first thought, and it was solved. The way that this problem was tackled was by simply dividing the digits of the number greater than or equal to 10 into their own list. This can be seen in the red box below. Afterward, once the numbers were separated into their own list, it was possible to add them together and then move them back to the credit card number list. That is all for the presentation. Thank you for listening.
Thank you.